This is SpaceTime Series 27, Episode 39, for broadcast on the 29th of March 2024. Coming up on SpaceTime, introducing the Einasto Supercluster, a new heavyweight contender for the universe. How humans changed the shape and orbit of an asteroid, and Hubble's latest images of Jupiter tracking its stormy weather. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers studying some of the largest known structures in the universe have discovered one of the most massive superclusters ever seen. The findings, reported in the Astrophysical Journal, suggest this giant structure comprises thousands of galaxies made up of some 26 quadrillion stars. Now, that's a 26 followed by 15 zeros. The supercluster has been named the Einasto Supercluster in honor of Jan Oort, a pioneering astronomer who helped discover the large-scale structure of the universe and who celebrated his 95th birthday on February the 23rd. The large-scale structure of the universe is the gigantic cosmic web composed of vast empty voids surrounded by thin filaments connecting nodes of galaxies, galaxy clusters, and superclusters. Superclusters are sort of akin to vast metropolitan cities in space, representing the largest and most massive collections of clusters of galaxies in the universe. The Einasto Supercluster is located some 3 billion light-years away and is something like 360 light-years wide. The study's authors, led by astronomers from the Tartu Observatory, discovered the Einasto Supercluster while observing some 662 galactic superclusters. They determined that the typical mass for a supercluster is an astonishing 6 million billion times that of our Sun, with an average size of some 200 million light-years. Now, to put that in perspective, these superclusters are approximately 2,000 times larger than our own Milky Way galaxy. The authors' findings not only expand science's understanding of these vast structures, but they also pave the way, shedding new light on the ongoing mystery of their formation. For example, the clusters of galaxies that reside inside a supercluster are heavier than the clusters of galaxies outside a supercluster. And this shows that the evolution and growth of clusters of galaxies inside superclusters are different compared to the ones found outside a supercluster environment. Now, although superclusters contain a substantial mass, the mass is distributed over a considerable volume of space. Consequently, they're actually less dense than galaxies. Nevertheless, their density is still sufficient for their gravity to impact the motion of matter within the supercluster. And that's important because observations show that our universe is undergoing accelerated expansion due to a mysterious force which astronomers are calling dark energy. It implies that the space between galaxies is increasing, causing them to move further apart over time. But the new study is showing that galaxies within superclusters exhibit lower expansion rates than the overall expansion rate of the universe. And that's being attributed to the gravitational pull of the supercluster, which counteracts the overall expansion of space-time due to dark energy by pulling back the galaxies. However, it's important to point out that this gravitational pull still isn't large enough to make superclusters a gravitationally bound system. Eventually, the effect of dark energy in expanding the supercluster will overtake its gravitational pull, leaving us in a few trillion years' time with either a cold, dark universe, where the nearest stars are beyond sight, or no universe at all, where matter itself has been ripped apart at the subatomic level. This is SpaceTime. Still to come, how humans changed the shape and orbit of an asteroid, and new Hubble images of Jupiter tracking its stormy weather. All that and more still to come on SpaceTime. A new study has confirmed that the asteroid moon Dimorphos was reshaped after it was hit by a spacecraft. NASA smashed their DART, or Double Asteroid Redirection Test Planetary Defense Demonstrator spacecraft, into the tiny moonlet back in 2022. As well as knocking the 170-metre wide asteroid moon off course, DART also gathered information on its internal structure and the effects of the impact. A report in the journal Nature Astronomy says scientists have now used computer simulations to recreate the collision as closely as possible. The impact wouldn't have left much of a crater, but it could have reshaped the moon in its entirety, a process known as global deformation. Importantly, the demonstration did prove that a kinetic impactor could deflect a hazardous asteroid should one ever be on a collision course with the Earth. And for the record, that's not a case of if, but when. Now, a new study published in the Planetary Science Journal confirms the early computer simulations, showing that the impact changed not only the motion of the asteroid, but also its shape. Before the impact, Dimorphos had a roughly symmetrical oblate spheroid shape, like a squashed ball that's wider than it is tall. It was in a well-defined circular orbit at a distance of about 1,189 metres out from its parent body, Dimorphos, and it took 11 hours 55 minutes to complete each orbit around Dimorphos. The study's lead author, DART navigation engineer Shantanu Naidu from NASA's Jet Propulsion Laboratory in Pasadena, California, says when DART hit the tiny moon, things got really interesting. Dimorphos' orbit stopped being circular. Its orbital period, that is the time it takes to complete each orbit, had become 33 minutes and 15 seconds shorter. And the entire shape of the asteroid did change, from a relatively symmetrical object to a triaxial elliptoid, something more like an oblong watermelon. The new authors did their own computer modelling using 3 separate data sources in order to deduce what had happened to the asteroid after the impact. The first source was onboard DART itself. The spacecraft captured images as it approached the asteroid and then sent them back to Earth by way of NASA's Deep Space Network. These images provide a close-up measurement of the gap between Dimorphos and Dimorphos, and it also gauged the dimensions of both asteroids prior to the impact. The second data source was the Deep Space Network's Goldstone Solar System radar located in Barstow, California. It bounced radio waves off both asteroids to precisely measure the position and velocity of Dimorphos relative to Dimorphos after the impact. Those radar observations quickly helped NASA conclude that DART's effect on the asteroid greatly exceeded minimum expectations. But the third and most significant source of data were ground telescopes all around Earth that watched and measured both asteroids' light curves, how the light reflecting off the asteroid surfaces had changed over time. By comparing light curves before and after the impact, the researchers could learn how DART affected Dimorphos' motion. See, as Dimorphos orbits, it periodically passes in front of and then behind Dimorphos. In these so-called mutual events, one asteroid can cast a shadow on the other or block out its view from Earth. In either case, a temporary dimming or dip in the light curve will be recorded by the telescopes. The authors can then use the timing of the precise series of light curve dips to work out the shape of the orbit, and because the models were so sensitive, they could also figure out the shape of the asteroids. What they found is that Dimorphos' orbit around Dimorphos is now slightly elongated or eccentric. Before the impact, the times these events occurred was regular, and that shows a circular orbit. But after the impact, there were very slight time differences, showing something was askew. In fact, the models are so precise, they could even show that Dimorphos rocks backwards and forwards as it orbits Dimorphos. The models were also able to calculate how Dimorphos' orbital period evolved. It seems that immediately after the impact, DART reduced the average distance between the two asteroids, shortening Dimorphos' orbital period by 32 minutes and 42 seconds to 11 hours, 22 minutes and 37 seconds. But over the following few weeks, Dimorphos' orbital period continued to shorten as it lost more and more material to space, finally settling in on 11 hours, 22 minutes and 3 seconds per orbit, some 33 minutes and 15 seconds less than before the impact. Now, these calculations are accurate to within 1.5 seconds. The study also confirmed that Dimorphos now has an average orbital distance from Dimorphos of about 1,152 meters. That's 37 meters closer than before the impact. This is space-time. Still to come, NASA's Hubble Space Telescope tracks Jupiter's stormy weather. And later in the science report, a new study confirms that global life expectancy dropped by 1.6 years thanks to the COVID-19 pandemic. All that and more still to come on Space Time. giant planet Jupiter in all its banded glory has been revisited by NASA's Hubble Space Telescope, providing new insights into the king of planets' ever-changing storm fronts. The latest Hubble image of Jupiter was taken back in January, and it clearly shows the gas giant's classic great red spot, standing out prominently in Jupiter's atmosphere. Big enough to swallow the Earth, this swirling anticyclone has been steadily shrinking for decades. In fact, over the past few decades, astronomers have noticed that Jupiter's most iconic feature, which has raged across the surface of the solar system's largest planet for some 300 years, has been slowly not just shrinking, but also fading. Now, the Hubble observations confirmed that the rate of shrinkage of this massive storm has slowed down in recent years, although it's still some 240 kilometers smaller than what it was in 2014. Jupiter's Great Red Spot has been observed as far back as the late 1800s, when it was some 41,000 kilometers wide. That's big enough to fit the Earth inside it 3 times. By the time NASA's twin Voyager spacecraft flew past the gas giant in 1979, the Great Red Spot had shrunk to a diameter of about 23,300 kilometers. And it continued shrinking with time, as Hubble images taken in 1995 measured the spot at 21,000 kilometers, and by 2009 it had shrunk to just 18,000 kilometers. Observations in 2012 revealed a noticeable increase in the rate at which the spot was shrinking, by some 933 kilometers a year, and it was also changing shape from an oval to a circle. Now the Great Red Spot's somewhere around 15,000 kilometers across and decidedly pale orange in color. But the storm's swirling winds still pack a punch, reaching speeds of more than 540 kilometers an hour around its periphery. Cyclones and their locally named counterparts, hurricanes and typhoons, usually spin around a center of low atmospheric pressure. And the planet's rotation, such as the Earth, Jupiter or Neptune, induces a Coriolis effect, which causes the cyclone to spin clockwise in the southern hemisphere and anti-clockwise north of the equator. But the Great Red Spot is an anticyclone, and they spin in the opposite direction. That's because they're created around an area not of low pressure, but of high atmospheric pressure. Over the past few years, astronomers have observed the Great Red Spot interacting with a series of smaller vortices, causing chunks of red clouds to flake off, further shrinking the storm in the process. Before 2019, the Great Red Spot was only hit by these smaller storms a couple of times a year. But more recently, it's been pummeled by as many as 24 storms in a year. Still, the Great Red Spot remains at least 6 to 7 times as big as these smaller anticyclones that are colliding with it. But even these smaller storms are still 10 times bigger than the biggest hurricanes ever seen on Earth. Some are even physically bigger than the planet Mars. A recent study reported in the Journal of Geophysical Research Planets claims these interactions are only superficial and that the Great Red Spot's actually gaining power from these smaller storms at the expense of their rotational energy. Images of these storms taken by NASA's Juno spacecraft in orbit around Jupiter show that the smaller anticyclones pass through the high-speed peripheral ring around the Great Red Spot before circling around it. These smaller storms create some degree of chaos in what is already a turbulent and dynamic situation, temporarily changing the red spot's 90-day oscillation in longitude and tearing streams of red clouds from the main oval. But scientists insist it's only affecting a few kilometers of the surface and doesn't have any significant impact on the overall 200-kilometer depth of the Great Red Spot as a whole. Of course, scientists still aren't sure what's causing the Great Red Spot to shrink, or for that matter how it formed in the first place. But they believe these smaller anticyclones may even be maintaining the Great Red Tempest for now. Another small red anticyclone has been detected in the far north. The storm actively appears in the opposite hemisphere, where a pair of storms, a deep red cyclone and a reddish anticyclone, appear next to each other. These storms are rotating in opposite directions, indicating an alternating pattern of high and low pressure systems. For the cyclone, there's an upwelling on the edges with the clouds descending in the middle, resulting in a clearing in the atmospheric haze. This report from NASA TV.
The giant planet Jupiter, in all its banded glory, takes the spotlight in these new images from NASA's Hubble Space Telescope that capture both sides of the planet. Big enough to swallow Earth, the classic Great Red Spot storm stands out prominently in Jupiter's atmosphere. To its lower right, at a more southerly latitude, is a feature sometimes dubbed Red Spot Jr. This giant storm, called an anticyclone, was the result of other storms merging in 1998 and 2000, and had first appeared red in 2006. The source of its red color is unknown, but may involve a range of chemical compounds, sulfur, phosphorus, or organic material. Staying in their lanes but moving in opposite directions, Red Spot Jr. passes the Great Red Spot about every 2 years. Hubble also captured Jupiter's volcanic moon, Io. Only slightly larger than Earth's moon, Io is the most volcanically active body in the solar system. Hubble's sensitivity to blue and violet wavelengths clearly reveals interesting surface features. Hubble monitors Jupiter and the other outer solar system planets every year under the Outer Planet Atmosphere's Legacy Program, or OPAL. These large worlds are shrouded in clouds and hazes stirred up by violent winds, causing a kaleidoscope of ever-changing weather patterns for Hubble to investigate.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown that global life expectancy dropped by 1.6 years during the COVID-19 pandemic, and that's reversing previous trends which were looking at longer life expectancies for Homo sapiens. The findings, reported in the Lancet Medical Journal, updates estimates from the 2021 Global Burden of Disease study, which estimated that the pandemic caused global mortality rates to jump among people aged over 15, rising by 22% for males and 17% for females. Australia had a slight 0.01% increase in deaths due to COVID-19 and was one of very few countries that saw an overall increase in life expectancy during the pandemic. Official figures by the World Health Organization show that over 7 million people have now been killed by the COVID-19 coronavirus since it was first detected among workers at China's Wuhan Institute of Virology back in September 2019. However, the World Health Organization estimates the true death toll is more likely to be around 18 million, with some 775 million confirmed cases globally. Scientists have developed a new camera system that can produce videos that replicate the colors different animals see the world in. Different creatures, great and small, see different color ranges, and sometimes they see different colors which humans can't see, such as honeybees and birds that can see ultraviolet light. A report in the journal PLOS Biology says the new camera setup is designed to simultaneously record video in 4 color channels, blue, green, red, and ultraviolet, and this data can then be processed using what we already know about how animals see the world to produce more accurate representations of their views. A new study has told scientists what dog owners already know. Dogs learn and understand what their toys are called. The findings, reported in the journal Current Biology, follow earlier studies which suggested that dogs don't do well in tests where they're asked to fetch an object after hearing its name. But the authors wanted to look closer at what was really happening in their canine brains when it came to object and name recognition. So they measured the brain activity of dogs while their owners identified a specific toy, for example, saying, "Look, the ball," and then presented either the correctly named toy or a random incorrect one. The authors say the dog's brain activity showed a different pattern when the correct toy was presented compared to when an incorrect object was provided. That indicates they really knew what the names meant and could tell when they were being tricked. A recent survey has found that most children stop believing in Santa Claus and the Easter Bunny by the age of 8. However, Tim Mendham from Australian Skeptics says researchers also found that once they find out that Santa and the Easter Bunny aren't real, about 10% of kids will never fully trust you again.
I certainly would have believed in Santa as a kid. when I stopped believing, I'm not quite sure. Was the evidence very good? Scientifically, yes, the evidence is very good for Santa. You obviously see him around all the time. At Christmas time, everyone talks about him. There's, Santa decorations and there's Santas in shopping centres. So obviously Santa is real. You have empirical evidence. But yeah, people tell Santa, bring some presents, adds a bit of romance and magic to a time when you think there would be enough magic around. And then the suggestion is that kids will generally keep on believing in it on an average till they're about 7 or 8 years old. I'm not quite sure if that's the case. Obviously, there's a bell curve here. Some kids very young will sort of say, no, Santa's not real. Other kids will hang on to the belief for much longer than they should. There'd be an influence of older brothers and sisters and friends, etc., or school friends who might sort of disabuse them of their belief in Santa, so that would be an influence on their changing beliefs as well. But of course, as we know, as skeptics all know, Santa's true, and he exists, and he'll bring me presents unless he becomes a nasty person. But it's a bit of an issue actually for skeptics. Do you promote the idea of Santa as an imaginary being who will bring you presents if you're good? Of course, that reminds you of various other imaginary beings out there who might, look after you if you're a good person. Throughout life, you pray or be good to an omnipotent being who will then bring you sort of presents wrapped up in Christmas time. So Christmas presents is obviously part of the Christian tradition of, the three wise men, blah, blah, blah. Saint Nicholas originally was a Turkish saint.
Saint for animals, wasn't he, Saint Nick?
I'm trying to think, actually.
Animals and travellers, I believe.
Animals and travellers, yeah. And it's developed over the years in various sort of cultures, with various places in the world, ending up with our image of the Santa Claus that we know, the big fat man with the red suit and a black belt, etc. It looks surprisingly
Coca-Cola
like
Santa Claus.
Coca-Cola sign, yeah. There have been variations of that before Coca-Cola. We've actually written about this in our magazine. But the image you see now of the jolly man with the white beard and the red cheeks and all that sort of stuff is definitely one that Coca-Cola has pushed very heavily and is now embedded in our beliefs. If you look at sort of Dutch Santas and Santas from 1800s, even 1700s, you'll see a very different character, somewhat more sinister actually than the one we have today. The question is...
I don't realise how recent all this stuff is. Christmas trees weren't around before the Victorian era. It was Queen Victoria's husband, Albert, who introduced that trend.
But where did he get it from? From Germany?
From Germany,
so
yeah.
It was there first. But the thing is, sort of Santa, as we know, it's only been around since about 100 years, or even less.
Exactly.
As we picture him today, the concept of Santa has been around for a while. But the question is, what happens when the kids get disabused of their beliefs? Do they say, oh yeah, that was fun, or do they think, horrible parents fooled me all these years? And one suggestion is that 10% of kids will never forgive you. Kids are very basic in their justice, in their sense of truthfulness and right. And if they've been lied to, they get very upset, whereas perhaps as adults become more jaundiced and people lie to us all the time. The kids take it very seriously. They take Santa very seriously. And they say 10% of kids will sort of harbour ill feelings towards you if you have told them this Christmas fib. I'm not quite sure why we push Santa, quite frankly.
We do. It's a commercial thing, isn't it?
Yeah, probably a big commercial thing, but it's also, you see it everywhere, so it'd be hard.
And it's good blackmail. You be good or Santa won't bring you
any
presents. That's
God, isn't it?
That way the parents aren't guilty.
That's God, isn't it? That's what God does as well. You have to be good, otherwise he'll come and punish you or not give you presents.
What do you think about this idea that some kids still believe in Santa until they're 15 or 16? I found that very hard to believe.
I find that very hard to believe unless they're sort of just milking it for everything they can get. For as long as they can get.
Smart, yeah.
I don't think they really believe,
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.